We're surrounded by microchips. Chips have changed how we communicate and how we see the world. Chips give us instant access to information, they store vast amounts of data, and in an unfamiliar city, they help us find our way.
ASML supplies the machines that are used to make these chips. All of the world's top chip makers are ASML customers. So chances are that every day you use a device that was partly made with an ASML machine. Based in Veldhoven in the south of the Netherlands, ASML comes from a country with a rich history in technology and engineering. On wet and poor soil, the Dutch managed to develop a rich economy thanks to technology and an entrepreneurial spirit. From the compact disc, which was in large part developed here, to the massive flood control barriers that protect the lowlands, Dutch engineers have shown ingenuity both on very large and very small scales. Making semiconductors involves extremely small scales. Features on a chip are measured in nanometers. That's a millimeter divided into 1 million parts.
What's a nanometer?
A nanometer, that's 1/1000th of a meter.
Let's say that your beard hair is growing 8 nanometers a second.
You cannot see it by eye. You need a microscope.
If you have a meter, you have like 1,000 millimeters in a meter. And if you make one step down, so another 1,000th of a millimeter, you get to micrometer, and another 1,000th of that, then you get to nanometers.
Imagine the hole of a needle, and a nanometer would be 100,000 times smaller than the hole of the needle you are trying to put the thread in.
ASML's lithography machines are at the center of the chip-making process. When chip makers produce faster processors or memory cards with higher capacity, semiconductor lithography was an important ingredient.
Our machines, to put it very simply, are used to print patterns on silicon wafers like this. And we do this layer after layer after layer, and thus we build a three-dimensional structure that then turns out to be a microprocessor or, for instance, a memory chip.
A lithography machine is essentially a projection system, not unlike a slide projector. Laser light travels through a mask, which contains the blueprint of the pattern that will be printed. A lens then focuses the pattern onto the wafer. The wafer has earlier been coated with a light-sensitive substance. When the unexposed parts are etched away, the pattern is revealed. Here you see how a transistor, the basic building block of a chip, is being made. A chip can have more than 1 billion transistors, and it can take over 25 lithography exposures and more than 250 process steps to manufacture.
Lithography machines operate with extreme speed and precision. Let's see how this vehicle, also known for speed and good engineering, matches up. So, Fritz, a chip is made layer by layer. What sort of precision is required in lining up these layers?
We call it measure overlay, and to have a working chip you need very good overlay, and these days that's probably about 2 or 3 nanometers. And if you compare that to the Netherlands, you could drive along this road for 3 or 4 kilometers, come back, drive the same route again, and between the first time and the second time you could not have a deviation more than 2 or 3 millimeters.
2 or 3 millimeters?
2 or 3 millimeters.
What about speed? How fast would I have to drive in this analogy?
Oh, in this analogy, the speed would have to be of the order of 600 kilometers a second.
How do you build a machine like that?
Well, we've been doing this for about 25 years, so originally the machines were not as good as this. They were probably a factor 100 different, but every year we improved, and that's how we got to where we are today.
Founded in 1984, ASML has grown into an international company with some 7,000 employees, annual revenue of more than 4 billion euros, and over 60 offices in 15 countries, including the United States, Korea, China, Japan, and Taiwan. ASML employs engineers from fields as different as physics, microelectronics, chemistry, and software to design and manufacture its systems.
At Asml you never stop learning, because the technology is always evolving year in, year out. So yeah, you learn from each other. It's not something you learn in a school that they teach. This is a problem and this is how you solve it, because technology is, the pace of technology is so fast that you only can learn within ASML.
Predicting the future is a tricky business. We're still waiting for personal jetpacks and vacations on a space station. What we do know is that chip makers will continue to make chips smaller and more powerful and invent new ways of using semiconductors. To prepare for that future, ASML has developed a new generation of lithography equipment called EUV. With it, chip makers will be able to make better chips for years to come. Chips that will entertain, help us communicate, and live safer and healthier. I'm Nicholas Mika. Thanks for watching.